Okay, should be live here. Hi. We're doing something a little different today. Whoops, does this thing not work? What's the stupid cloud command? I thought it was just Claude, is it not? Oh, I'm in the wrong tab. That's fine. So here's the plan today. Um, I will let the stream start up a little bit before I go over the full thing, but I have a real task that is actually part of my work. Um, and I'm going to try to use Claude for it, but I'm going to try to use it in a completely different way from before, in which I'm going to actually be steering most of the code directly. It's going to look very, very different, and we're going to see if this is useful. One moment. All right, there. Hey, Muffin. How am I supposed to watch Yaxine and you? What are your thoughts on the RLM paper? What RLM paper? Oh, the recurrent line. Dude, why do people expect that I've read this shit? Like, why would I have read that again? Like, I don't work on oops. Cool. Thought there is a Claude MD, isn't there? Maybe not. It's fine, we'll do this. Let's see how it goes this time. This is going to be very different. Yeah, seems interesting, but that's not what, like, I don't do that stuff, Muffin. I got my hands full with the RL I work on. So, okay, I'm trying to think when I want to give the overview of what I'm doing. I think once I have this thing fully set up, hopefully that will allow the stream to have warmed up a little and I will talk about exactly what I'm using this for. This is going to look very different from the other day. I think that was the most depressing stream I've ever done the other day. That was like completely stupid. Oops. What the heck is it trying to do? What's the plan for this attempt? It will be very different. Let me finish going through the setup here, and I will say exactly what we're doing. Okay, so last attempt, I will give, before I say the actual details of the project. So last attempt, it was, look, the idea was, hey, everybody's been telling me these models are super good and you should just use them. Let me let you guys tell me exactly what to use, how to use them, so nobody can say I was using them wrong or whatever. Lo and behold, the models are good, but actually the users are even stupider than I thought. I don't think I did a single thing last stream that I couldn't have done blackout drunk. Like, I could have done every single thing I did on the stream, provided I could stay awake. Like, I could have probably slammed a whole bottle's worth of vodka Red Bulls and still been able to do that. And that's not good. So today we're going to try something very different, where I actually see, okay, the models are pretty good. The usage pattern is brain dead. Let me see if I can come up with a better way to use this that does not involve a full frontal lobotomy. And I have a new project for that is less standalone. It's a substantially harder project in some ways. But it's one where the pieces that are hard are things where Claude should be good, and it's mostly like fiddly docs and fiddly testing and stuff. Okay, perfect. So, really high bar. I think thinking should not be a high bar. Why depressing? Because basically all of my viewers were very happy to just not think at all. It was very, very odd. Okay, so this is the plan today. I have a little task that I need to do. It is something that I know exactly how to do. I know exactly the ops that should be specified. I don't really know the library functions to call. There are a few other things, and it's something that would be kind of fiddly for me to set up manually. So what I want to do is I want to really have a lot of control here and essentially use this as much more powerful fuzzy docs than before that is also applying those changes. So I'm going to retain almost as much control as I have in my normal programming, but the hope is that instead of this thing saving me thinking, this thing saves me bullshitting. Because, a lot of the work that I normally do when I'm dealing with low-level, poorly documented stuff, or just new stuff, there's a lot of bullshitting. So hopefully, I'm going to be able to use this thing to allow me to focus on the actual building, not like the high-level, super underspecified, no, the actual precisely specified thing that I want, only really using this thing to help me get those details quicker. Okay, and the project, it's a kernel benchmark project. I have some benchmarks in Python that are benchmarking our kernels from Torch, and I want to figure out how we're going to have these benchmarks also work on the raw CUDA kernels without Torch in the mix, and then from Torch C++. I pretty much want to get us a full microbench suite. And this is a project where pretty much everything is incredibly verifiable. I've already done the structure of everything. And yeah, I want to go from there. So let us see. Okay, so this is our current microbench. I I'm trying to remember if I had some sort of thing. I think I did have like some sort of basic script from before. Let me go grab it from I just want to go see if I had my script set up from before. Actually, that thing was bad anyways. Was it? I think I can still use it to start. Hey, Luke. Try to approach it as TDD. Nope. What did I say? I'm not taking any stupid viewer advice today. It's going to be similar in the sense that there's verifiability, but it's not going to be TDD. Last time I took, all I did was take viewer advice. It was the most depressing goddamn stream I've ever done. I went out and I had 4 margaritas after that. That was awful. Okay. Right, profile. It's this file that I didn't commit. Okay, so I'm going to take this. Viewership for first stream. Don't care. Now I'm actually trying to do something useful with it. I did the first stream because people really wanted to see, and that'll give me enough for the article, but I'm trying something different. This is still the bad timeline AI-wise. I think it doesn't have to be. Okay, cool. So we have this. Yeah, this now works. GPU performance counters. I don't know whether we need those or not. Fine. what is it, Shift Tab? Cool. Just glad it was Margs and not RuneScape. Yeah, I might have also downloaded that. Yeah, I might have downloaded the game again. uh, yeah, yeah. But let me tell you, I am actually very optimistic about the direction of Puffer and Tech. Um, I think it's based mostly just there is more signal than before, but there's also just way more noise. So the ratio sucks, but like I can pick it out. You have a lot of hope in people? I don't have a lot of hope in people, yeah, Persino. I have hope in the potential of humanity. That's what I have hope in. Profile has log code and values. Launch. Cool. So right now, I've given it so far like no control over this. This is literally just gonna remove like delete this and then paste in the other stuff. But my hope is I'm gonna be able to use this to speed up the dev loop for benchmarking and to like, well, without really giving it much control. In the meantime, we can start reading this. So yeah, this just gets like a vector. Oops. Step one. No, this is bad. Uh, I don't know why it's doing this. What's this post convert? It's a relatively well-known bug. I mean, I'm not surprised when the devs of this thing apparently write all their code exclusively using it. Torch headers. Soft plus threshold. Soft plus threshold check. Okay. Okay, that's an incredibly obnoxious bug. Holy crap. Really likes its RMRF. I am in a standalone container, especially that's just for this. Because of their RMRF. Okay, so the launch wrappers. Ah, I see. That's fine then. So what we'll do is we will do. I can pass the stream to the launch function, right? Move all launch functions that use. No. Ah, shit. CUDA. Yo, why is this why is it like flashing like this? Is there like not a way to fix this? CUDA stream T. Does it get converted somehow? Because this is a torch object. So actually, how does this go here? Does anybody know? Like, because this should be a CUDA object. This is torch, right? So what we want to do is like stream.handle or something, and then pass it as an arg. It's the terminal emulator. This is default Ubuntu, like whatever the default Ubuntu term is. Launch. Stream explicit. I think this works. Yes, this is what we want. Do a vibe code? No, this is not a vibe coding stream. I did the vibe coding stream last time and it was the most depressing shit imaginable. This is much, much more precise. It's fine. What's the difference now? I mean, before you saw I was just like programming in English. This is the opposite, right? I'm actually like, I'm doing most of the code here. I'm going through line by line and fixing stuff. I'm basically using this to automate like syntax, docs, lookups. This is a much lower level of shit. I resume this. Is there a resume or did I just hit escape by mistake? Let's see. Whatever. Okay. Do you publish article? No, I'm waiting until after I do this. Resume. Yeah, flickering, weird. Dramatically different FBR, you will see. Okay, so yes, this is what we want. Equals 0. Equals 0? No. Yeah, so that is what we want. Opus without brain damage. Opus with brain damage was the last stream. Zero thinking happened last time. It's backward. Yeah, this is the same change. Good. Yeah. So these are all just all the launch functions. Okay. So then this will make us have, we will then have a standalone, we'll have standalone kernels and launch functions. And that lets us write a test script that doesn't depend on torch. What did it just do here? Oh, that's fine. Yeah, I can do that. That's fine. Matterchurch is gone up and for the develop because basically I'm trying something different today. So last time it was okay, let just hand over control to Opus because I was listening to viewers and I was like, okay, how should I use this thing? And basically everybody told me to use this in the dumbest, least thinkingest way possible. So now I'm thinking, well, what if I'm doing my normal work and I want precise control over every line of output code, like I was working normally? Can I use this thing to help me in my normal work without making me actively stupid? So I mean, if you're looking closely at what I'm doing, this looks nothing like what I was doing before at all. Like this is essentially the level that I'm using this at now is essentially just preventing me from screwing up like function calls and screwing up like typing and syntax bugs, right? While also automating like fuzzy changes to like very similar changes fuzzy to several parts of the code at the same time. No, I'm not the architect, it's the builder. That's too high level. That's the thing. And then this needs C10 CUDA stream, yes. Like giving up the responsibility and complaining. Yeah, Liberty, but like I said I would do one stream listening to exactly how people wanted me to use it. It was dumb. So now we're trying it different. This is not great, Olm. This is so the project I'm working on right now. This is a real part of Puffer 4. This is it's a very verifiable task. I already have code for this for the sort of Torch Python layer of it. This is a kernel benchmark. So we are writing a kernel benchmark for all of our custom kernels for Puffer 4. Complete handover. The complete handover is utterly stupid. Completely and utterly stupid. Like, you should actually just be embarrassed with yourself as a human being at that point. I don't know. I don't even know what to say. That was the most depressing. I think that's probably the single most depressing thing I've ever done in tech. That was awful. Okay, so once we have this thing done, we can probably come up with a pretty good standalone, like raw kernel level benchmark. I still have to figure out how we're gonna do torch benchmark and kernel benchmark at the same time. I think I know though. Are you not using any LSP? Fuzzy replaced with just regex. Yeah, this is like a fuzzier LSP, and so, no, this is more than a fuzzy LSP. This is more than a fuzzy LSP. Super Maven is a fuzzy LSP. This is substantially more than a fuzzy LSP. But the key is I don't think I'm really giving up any low-level control doing this. So what did this do? This did static cast. Ah, no, this is fine. Stream is good. The LLMs are better than expected. The users are stupider than expected. Yeah. People are using these tools because... No, I'm saying that people are using these tools because they're incapable of thought. Or not even that they're incapable of thought, it's actually substantially worse. Several of them are capable of thought and do not want to think, which is, in my view, much worse. So the idea of today is, can we use these tools in a way that I'm thinking exactly the same amount, if not more, than I normally am? I have precisely the same amount of low-level control, but I'm able to get my work done more effectively. And a key piece of this is I am considering the code part of the final product, not just the result, okay? So both the result has to be at least as good and the quality of the code has to be at least as good as well. Do you prefer this over manually coding? That's what I'm currently thinking, Robin. That's what I'm currently figuring out. I am going to be doing some stuff manually for sure as well. But like, look at these diffs. Do you see how tiny these diffs are? It's using way too many freaking tokens doing this shit, but that's not a huge deal. Yeah, so that's what I was doing before with Super Maven After Story, but um, you know, because you still have stuff like making the same fuzzy change in multiple places, it's a lot easier to mess stuff up. What the hell did you do? Okay, no, this is fine. Right, this is expected. Yeah, this is what I asked you. This is removing duplicate. And then yes, that's correct. So this is just all copy pasted duplicate code. So this looks like a big diff, but this is literally just removing duplicate code. And then the actual diff is right here. Yeah, you can do this. Corporate, and you don't have any deadlines in corporate, man. People do zero work in corporate. That's bullshit. The vast majority of industry engineers, even the well-paid ones, are doing essentially nothing. Everybody loves to pretend they're so busy. Okay, this still runs. That's fine. Effort to save tokens. Yeah, but the thing is, I'm not sensitive, so I'm not super sensitive to the cost of this stuff. And if this improves my productivity by a little bit, or it makes my job a little bit more enjoyable, that's fine, right? The thing I didn't like was this thing just making you intellectually lazy and replacing your conscious thought and your control over the project. That sucks. All right, but if I can use it to not do that and do the opposite, then that's great. So actually, the only thing that you're not going to hear me complain over is the price of tokens. Yeah, we can do micro bench, I think. That's fine. Okay, that still compiles. Good. Low level controls must, yeah. I don't even really want them to help me design anything, though. I don't know why. I don't know why it tries to why it ingests the output of every command by default fully. But whatever. Okay. Yeah, very context inefficient. Actually, I won't complain about the tokens, but the context inefficiency is very stupid with that. That's fine. Now we have our kernels. I don't like how it spaces this shit. What the heck? 1, 2, 3, 4. Why would it be spaced like this? There. It's better. Whatever. Host launchers use default stream. Fine. Give me this. Okay, so now, before we add more of these, we want to think about the allocations. Let's look at the rest of this test. Yeah, so what we want is, oops. Okay, so what we want is we want something similar to this, where I have a test function that can test with a bunch of shapes and stuff. I don't really care too much about the tokens, to be fair, though. It's not that big of a deal. It's like mildly annoying at most. Using $5 in 45 minutes is not, like, that doesn't matter. And that will get cheaper and faster as well, like very rapidly. So what I'd like to figure out, guys, next, did you do any specific setup to make it easier to use in this way? No, I literally just stop. I just don't outsource thinking to Claude. That's it. I guess having tight verifiable loops on stuff like quick compile commands, stuff being pretty standalone. But like that's how I would normally dev stuff anyways, because that also makes it easy for you to dev. So I really don't like the idea of changing stuff to make something easier for the LLM and harder for people. But in this case, it's perfectly aligned. So here's the question then, right? Like, I have this profiling set up in Python. This is for the Python torch binds. So the question will be, how do we do this in C++? Because I think ideally, we don't even have this script at all in Python. Because like measuring Python overhead is just dumb. There's not really a point to it. Like obviously Python is just slow and stupid. And like if I were to take this loss for instance and I convert this into C++, the code actually doesn't even get any more complicated. So yeah, the Python is kind of just worthless. The thing that I do need to figure out though is how to do some sort of thing like this where you just pass all the args in. I think what we're going to do we need something that allocates us tensors for all the args. We need something that allocates us tensors for all of the arguments. And then it's going to be able to pass them in. I can do it with one void star. I don't know if there's anything better. Random question, how are the degrees PhD and Doctor of Eng perceived? I've never heard of D-Eng. What? It's just PhD for whatever in the US. And then there's a lot of variants. I definitely don't go, like, unfortunately, some people do just go off of credentials. I always just go by what have you built. Okay. So if we were, I think that the way that we design this, right? Like, obviously this all gets allocated on, these all have to be allocated by raw CUDA. You can bind these to torch handles. Yeah, you can definitely bind these to torch handles. Put it into a struct, maybe. I think we can put it into a struct. And then we'll just have the test function take a void. We'll just have the test function take a void star. Yeah, I think we can do it this way. But we need the compact first. Yeah, the next thing will be, let's get these all CUDA mallocked. We're going to keep this C style. The correctness checks here. The correctness checks only need to run at the torch level. Cannot type today. So the function we want here Yeah, I think what's going to look like is this chunk of logic, right? This is going to get into we basically just need to have it so that this loop here gets shared across kernel tests. And this is not just to avoid redundancy, it's so that we don't screw up like tests on a specific kernel, so we know they're all the same. And also, I don't like these just massive test functions. We're gonna just do it with, I think we're gonna do it with structs instead. It'll be better. And this is kind of the main thing that I wanted to test today, guys, because like I know pretty close to what the code should look like for this, but it's still pretty fiddly, and it would still take me a fair bit of time to do it manually, and it would get kind of boring. So I think that this will be substantially better. Okay, so we have, what are we doing? We're removing the launch forward. Okay. We have this. It's fine to put them all in one struct, yes. We move the logic over, yeah. We do launch backwards. This gets removed, right? Has to be a 3. Eh. This is almost right. Almost right. Wait, you can't do that in C style, right? Like this is turn. Okay, yeah, this is a C++ thing. Okay, so very small change. I want this done C style. But almost fixed. Right? Well, I mean, come on, think about what I just asked it to do. Like, I asked it to do a pretty small manipulation where you're basically just chucking these into a struct allocation, right? Okay, let's see what we get here. Okay, we get our calec. We get this, we get this. And we're happy, right? Yes. Introduce and extract method. What I just did is a fair bit more than that. Like, you're right that it's almost what you could do with tools that are not fuzzy, but it's not quite the same, man. But you are pretty you are right that I'm using this in a way that is like almost pretty close to a standard IDE. It is still a little fuzzy, right? Yeah, so this is a test, right? Like, I'm assuming that these models are going to get way faster. I could always use the dumber model as well. I haven't even tried that. I don't even know if there's a huge difference for something as simple as this. Okay, so this still works. We don't need all these comments, Claude. So you can stop that. Let's see what this looks like. We have this awful name, but whatever. Yeah, I don't like these vectors. See, this was also from a model. See, I would have never typed this myself. So we're not going to keep this garbage. What even is this? Vector of float. I see. Okay. Yeah, that's dummy. Anything else that I don't like here? Hosted device. Other than that, this is fine. Yeah, this is fine. Do that first. Okay, you can do that. Yeah, that's a personal choice though, 20. I don't know, maybe in the future that will determine who is worth a damn and who isn't, right? Like who actually just wanted to be completely free from all conscious thought. Yeah, so this like thinking time, very stupid for something this simple, but to internalize, you know. And the thing is, like right now, this is arguably not even that much faster of a keyboard at all. Um, what the hell did it just do? I think I'll have to fix it a little bit. Where's my Super Maven? A lot of university students, then they shouldn't be in university. Go to trade school. Like seriously. There we go. This is what I wanted. Does this have to be Does this have to be allocated? A little annoying. Not terrible. Run that. Okay. Now we actually have a pretty decent start on stuff, right? Let's try. Timing meter, average MS, average MS. I don't know if we can do it. This as a void star because it needs to know the args, doesn't it? Maybe. Let me think how this works. Can't use voiceover and convert the type. Yeah, that's the only thing I'm not positive about because I don't actually, I try to avoid this when I can. I think in this case you have to. Type def void. Run functions take void star. Okay, so it's just when do you cast? Let me see. So in this one, this one takes a void star. It would be better. Wait, does the second one even work? Not a huge fan. Uh, yeah, but like, how do you, like, what else do you do in C, my guy? There are very few situations where you should do something like this, but when you have a giant stack of methods with each take an arg, and like you need to apply the same thing to them, this is what you do, right? Because it's either this or a massive block of if else, and like it's not just one big block of if else. It's probably like before, in the middle, and after. I think this is fine as well, especially for standalone test. Ooh, okay. Wait, aren't these like, wait, hang on. What? Now I'm confused. Run log. Wait, it just gave me two identical things, didn't it? That's why I'm confused. These are actually cast function pointers at call sites. Oh, I see. I see it. I'm gonna see what this looks like. This feels substantially better, I will say. All right, what are we doing here? So we're just getting rid of the old one, right? Yep. Cool. And that's way better, right? That's way better. Okay, so this feels like outsourcing the calculator. The other thing from the other day feels like outsourcing your whole brain. This is much better. And then this still works. Cool. Profiling. The new take. It's gonna be there's gonna be a pretty long article, I'm sure. I think it's that the models are good, the users are stupid. And the developers of these models are also just kind of evil. Is it faster though? Well, Igor, this is making my work at the very least substantially less irritating and obnoxious. I think this is actually allowing me to write slightly better code than normal. So I like this to me, and I'm not losing any control. So I think that this is pretty good. Copilot with a good UI. Yeah, I'm not trying to outsource my thinking. Best time to be a student? Um, the thing is, like, if you ask these things to just write better code, they don't really know what that means. And these things absolutely do encourage you to be intellectually lazy. Okay, so this is create, free. Yeah, so this thing is going to have to get pulled out next. And oh, these run functions are redundant as hell, right? Yeah, these run functions are... So we can actually clean this up substantially more. Cool. Yeah, we can clean these up quite substantially. I'm going to use the restroom real quick. And then we're going to continue. This is way more enjoyable. This is way, way, way better. I will be back. Making a cup of tea as well. Okay. And this is good. This is very good. Was it doing differently versus last stream? You can take a, I mean, watch and you'll see. It looks nothing like what I was doing before. Just conditional sampling. I don't think this is probability and statistics. This is just like interface and like, do you want to outsource your thinking or not? Like the difference as well is here. What I am doing now, right? What I'm doing now, I could not do blackout drunk. What I was doing last stream, I could do blackout drunk. This requires the like pretty much the exact same amount of thought that I would do normally. But what this is going to save me, I hope, is like this could save me an hour or two a day of like just screwing around with syntax errors and like me copying shit around wrong and like stuff like that. And like me forgetting bits of syntax because the project has CUDA, C, C++, and Python. I miss stuff up. I mix stuff up every so often, and like applying the same transformation to 5 functions, messing it up here and there, like stuff like that. Dude, after that last stream, I like directly went and got 4 margaritas. This was like the most depressing shit imaginable. That was awful. Okay, so what about these run functions? Are these actually needed? They're not, right? Oh, yeah, they are because, but actually they're not fully needed because, yeah, so what we're gonna do is we're gonna do like this. Replace, uh, project in main, Alex, is etc. Ooh. Okay, there's one thing that we have to figure out here, which is I still have to pass a no arg kernel, don't I? I still have to pass a no arg kernel. Okay. Minor refactor on that, and then the thing that I have to figure out is if there's a way to get rid of this run annoyance. Would be nice. Okay. Yeah, we get rid of this, we go to printf, that's fine. Oh, I see. Yeah, that's fine. Whoops. Actually, no, wait, is this good? Print log codes and values. Function. Okay, it's good. Just need that. Okay, so I mean, this can go up top, right? Yeah, this can go up top. So for this kernel, we have a struct, we've got a create, we've got a free. Is there any way to compact these three into one cleanly, or not really? Actually, here, sanity. We can use it for sanity. It seems bleak. It really doesn't seem bleak. Learn to code, man. Here's the edge that you have. The vast majority of entry-level people at the moment are just being lazy. So, all you gotta do is not be lazy. What's different with the approach? I mean, look what I'm doing this time. I'm not just outsourcing everything to the model. Change launch signatures to take a struct. Oh, that's invasive. Yeah, not really. Cool. Okay, we keep it this way then. Uh, well, actually, Also, how big was OpenAI? Like 100-ish? It was really good when I was there. So for all my criticism now, I always say that OpenAI when I was there was the best place I've ever been by a mile. It made both Stanford and MIT look like a bunch of idiots by comparison. Like that was actually awesome. What have I missed? We are doing a brain cells required Opus stream. So I'm basically trying to see if I can do my normal work, but I can do this in a way where this actually makes me more effective and does not really replace my thinking. Okay, let's see what this is. That's way too much code, Opus. Depends on how this experiment goes, 20. Depends on how this experiment goes. I'm also probably going to try Sonnet or whatever, because I wouldn't be surprised that Sonnet does just as well at this. Like, the main problem with this right here is this thinking time. This is really annoying. This, like, breaks up my thought process, but I think it's still worth it. We will see. Huh? I think so. This should look like if you should need hired any people. I mean, I'm working with Spencer. We're still technically doing things on a contract basis, though equity is available on contract basis as well, because it's easier. But he's basically working on this, most of his time. So I don't have full-time positions. Things are still officially done via contracts and are structured for contracts. But you can do enough stuff that it basically becomes the full week. Sonnet will be slower. What's the fast one? Is this the fastest one? I mean, presumably the models get way faster very quickly. So the only problem is they'll keep deprecating the old models, so you use the latest one, even though the older ones are going to be way faster. I too. Is that model decent though, or is it going to just make a mess? I mean, I'm doing pretty basic refactoring. Okay, profile kernels. Ah, okay. Yes, we will. Let me think. Is there any way around that? You want to be able to run. Let me think. Yeah. So I would want to put it in kernels. I'm trying to think if I want to do. I mean, obviously I can just do that, accept that, and fix it. Well, we don't have to change our kernels. What kinds of sims do you build for clients? There's one commerce sim that's open source that I'm still working on off stream on new versions. There's one thing in defense, another couple in finance, and we're looking at some game stuff this coming year. We've done a few other things as well. Yeah, see, these guards are pretty gross. I don't like this. Okay, let me think, is there a better way we can structure these tests? will be better. It's pretty funny. I'm using it pretty much the opposite of him now. Okay. CUDA kernels. Profile with torch. Checking Popperlip code base, notice it is header heavy. Yes, it is in order to keep it simple. Simplicity is way more valuable in RL than elsewhere. So the single file thing is preference. You don't have to put stuff in the single file. The reason that I like to put stuff in a single file very often is because you see the line count of your project. And, if you're a good programmer, you should have in your head roughly the amount of code that you think it should take to implement something. So if you see that you have twice the amount of code that you know that it should take, you know you're being dumb. Whereas if you have it spread over a bunch of files, it's way more easy to like creep the complexity of the project without realizing it. No, 24. What the fuck is that? Yo, what the fuck? It must have compacted or something. Oh my god, what is this scrolling bug? Anybody know how to fix this flicker bullshit? My term 2. This is just default Ubuntu term, I'm pretty sure. Okay, good. So this is yes. Okay, this is good. This is what we want, right? Yeah, but it's like a header only style thing, but was. You don't need I don't need declarations like that. No, you don't need to have the code twice. Okay, I might try that in a bit then. I could try, oh, I have Ghosty on this, don't I? Ghost TTY. I don't even think I put that on this machine. I stopped using that. Actually, here I can add it myself. That would be way better. See, it's like encourages you to be so lazy. You can't be lazy with it. Okay, so it's log codes and values dot apply. Dot backward. So it is a function here. Tensor run log codes and values. Profile. Yeah, so most of these are become internal then, right? So we can just do like March. Tough content creator, cannot watch every stream, cannot keep up. Man, this is not even crazy hours for me yet. This is like pretty chill hours. We do get like some good 50 plus hour stream weeks on the farm. I usually don't work quite as many hours when I'm in Florida, just because it's logistically way easier to work more hours out on the farm. But I do what I can. Yeah, I'm in Florida for the winter. I move around seasonally, so you prefer the heat? No, I really don't like the heat. A few months out of the year in the winter, it's not that hot, mostly. Awesome setup. Yeah, that's good. I spend a bit of time in California as well. And kind of move around between three places. I mean, the best setup is by far at the farm, right? I got like my whole crazy warehouse and gym thing. But there's like a really good serious gym 10 minutes from me here. So that's pretty good. It's not as nice as having all my own stuff, but they have way more stuff. So that's nice. And that gym is kind of fun because, if I go to just like your typical gym, I'm in pretty good shape, you know? Like I'm in pretty damn good shape. If I go there, I'm like weak, man. Like there are guys there squatting 500, deadlifting 600. Hell, there are women in there deadlifting 4 plates. It's crazy, crazy gym. So it's kind of fun. I did sub 7 minute pace though on the treadmill yesterday for a 5K, so I was pretty happy with that. That's a PR. That's what, like 22 minutes, just under 22 minutes, something like that. Well, yeah, I finally got myself some PT set up on my shoulder finally. So my shoulder just has not worked properly since before the summer when I hurt it. I can figure out what the hell's wrong with it finally. Okay, this thing is obnoxious. Oh, actually, no. What we can do is, no, I know what we can do. Like this, right? And then we do, arms like this, right? Yeah, we're gonna do like this. I think this is a decent design. Okay, there. That's way better, see? We wrote the scaffolding of it. I think this is reasonable. I don't like these guards, but this is a decent start. And we'll see how this looks. Let's see what we got. Okay, gets rid of this. Good. Use torch. Okay. Interesting. Args. No, this isn't gonna work nicely, is it? Try this instead. This definitely does require you to just not get lazy, though, because, it's always so tempting to just, Claude, figure it out, right? But you don't want to do that. What the fuck is that flicker? Well, you see, the devs of Claude Code just vibe code everything. So the actual application itself kind of sucks. Okay, so what do we have here? So, fair. Yes, this is what we wanted. We wanted from Blob. Yeah, this is what we want. Yeah, very close. They do that, yeah. This feels so much better than the shit from last week. I still don't think I'd want to do this with everything though, right? Like, I think that there are going to be, like, if I'm writing a new sim, I think that there are definitely going to be times where I want to still pretty much just be writing all my own code line by line. Um, this is nice because I'm kind of forced to play with Torch and CUDA APIs at the same time. So I am really like, this is kind of the ideal use case. Can't calc a struct containing them. Really? Huh. Is that a thing? Let me think. I didn't know that. I actually can't think of why that would be the case. Has a constructor. Oh, fine. Yeah, I see. Okay, you'd have to call new on each of these tensors. So yeah, I think that's fine. Yeah, yeah, I forgot. You can still do it. I see. Ways to duplicate variables. Hmm. Okay, let's look at what we have. So we've got the torch version of the struct. We're sharing memory, which is what we want, right? Run forwards. Yeah, we got this. Names are super long. We might have to think about that, but then this is exactly what we want as well. This is get CUDA stream. Okay, yes, we can keep this for now. Good. Let's see what we have. We're gonna definitely do something for these prints. Oh, that's pretty good. Now this is not profiling our module level stuff yet. This is just profiling our kernels. libtorch, I need to know how to get those. Yeah, that's fine. just once are includes, that's fine. D, use torch. Actually, here. I'll just copy it myself. It is good and fast. It's actually not good and fast, Reds. It's actually really not. So you need to do quite a bit of legwork. Um, the reason I'm using the C++ is you actually need to go lower level than just Torch. You need CUDA graphs and custom kernels. And at least if with a C++ API, I'm closer to the point where I need to be in order to do that. If you just port to libtorch with big batches and stuff, you actually don't see much of a difference. You kind of need everything. Hmm. We set up a standalone compile, don't we? Okay, let's see what this looks like. Build ext. Let's go check what this looks like versus our other ones. Hmm. Why is it through a sub-process? It's a little wonky, right? I think because you have to import it from Python otherwise. Yes, so we'll try this. Mm-hmm. I think it does need to be built as an extension. Maybe that you can just include syspath, I don't know. Okay. Profiles, kernels. Let's run. Nope, this does not run. Why would it be missing that? It's probably just a build flag, right? It should be LC10 here. RPath. Okay, this is kind of a hack, but no, this is still nice. I think this is still nice. What are we doing today? I'm trying to use Opus actually productively without giving up any control over my code flow. And it's going pretty well so far. This is actually way, way, way better. Linker RPath. No, this is so this is now a kernel benchmarking, a kernel benchmark for the custom kernels we have in Puffer. And I thought that this would be a good project because it's like very strongly verifiable. It's it would be dramatically annoying for me to do myself because I know pretty much exactly how I want everything written, but this involves, the CUDA API, the Torch C++ API, a bunch of setup and build crap, right? So it's like very annoying, and it's a task where like I can retain pretty much full control over everything and just do it a lot faster and a lot less painfully. Okay, so what do we have here? Cannot initialize. Interesting. This is basically because we're hacking the build sys instead of dropping a proper extension. Oh, hang on. Maybe this is fine. Try this. Weird torch setup. No, this is not an N. This is like custom kernel work on Puffer 4. I like this because the logic of what I'm doing at the moment is fairly simple. The design to keep it not a mess is non-trivial, and I have to do it myself. But then there's a lot of annoying syntax and a lot of annoying setup. So it's a pretty nice test case. There we go. Okay. One day Torch will be less. Honestly, Torch is just absolutely terrible engineering. Like, there's so much stuff in Torch that's just crap. Um, yeah. Opus is going well. I need to write a full article on it. Like the article, the thing is, it's not going to be a "it's good, use it" or a "it's bad, don't use it." It's going to be if you use it this way, like it will make your work moderately easier and like let you spend less time dealing with bullshit. If you use it this way, you're basically lobotomizing yourself. So it's not quite as simple. There are definitely a ton of things people were saying though about it that are just straight wrong. Like, oh, it takes skill to use. Bullshit. No skill to use whatsoever. None. There's like no LLM usage skill. It's just there's programming skill and there's intellectual discipline. That's it. Okay, so with this kernel, we have, yeah, so the forward stream is not using the correct calls here. There. So what this is doing here, right? So this is now all the memory is being allocated in raw CUDA. It's being bound to torch. And now this is calling the kernel with those data pointers. But what we actually need to do is then we need to call the torch module so that we can get the overhead from that. What not to delegate to a dog? What you should not delegate is your thinking. That's it. Like if you go in with a large amount of intellectual discipline, caring about the code that you're outputting, not just what it does, um, What else? Oh, and a very heavy disdain for abstraction, which is just generally good programming. You'll probably be fine. But like the interface and the advertising around this is the most aggressively anti-human thing I've ever seen. It's awful. So yeah, so this is wrong. Yeah, so this is genuinely a little bit tricky. On co-ops outlog vals. Yes, so this is, yes, you remove these, you add these. Outputs. I think this is fine. And then retain graph is true. And then you do launch. Yeah, torch autograd backward. I think this is good. Let's double check when I can see the full thing. So it's a little weird because we need to do separate forward and backward profiles. Let me look at this. So we have, yeah, this one is fine. Run once to set up outputs for backward. Intellectual discipline. So basically, this model, the way that this UI is set up and the way that they have positioned Claude, it is designed to make you lazy and to make you outsource your thinking. This is terrible. This is the intellectual equivalent of jumping out the nearest window. don't do that. What you should be using this thing for is for like removing the bullshit work that you normally do that is associated with like figuring out how this stupid function interacts with this stupid function because it's not documented, and like writing little tests to figure it out, and refactoring this massively bloated syntax to this other thing, stuff like that. The stuff that's really not thinking, but actually interrupts your train of thought quite a lot while you're trying to actually do everything else. That's what I'm like. That's what I'm sort of moving towards, opinion wise. I don't think you need it for everything. I think, for instance, the value of this goes down dramatically if you're interacting with exclusively well-designed libraries that are nice and succinct. Then the value of this goes down dramatically. Um, for stuff like this, it's pretty good. The code that I'm getting out of this is the same quality as the code that I would write normally, because I am actually like exercising control at that level, right? If I just told it to solve the task or something, then it wouldn't be able to do that. Oops, let's not do that. Oh, stupid. What does this regex match? Yeah, that's totally fine sounds. Yeah, whatever. That's one line. It's kind of silly that it just like, oh yeah, that's gonna take me 2 minutes to do that. That was kind of dumb. But whatever. So let's try this. Would one generally not use writing and I have a model? What? You can still write your own code. I've actually several times on this stream, I've written basically the full logic of what I wanted, and I essentially just had it fill in some syntax. Because so this project specifically, right? Think of all the things I have. I've got CUDA kernels. I have CUDA Stream API. I have Torch CUDA Stream API. I have Torch libtorch C++ API. I have Python binds. I have a lot of crap going on. It's a lot of syntax to keep straight in my head, right? That's mostly what I'm using it for, which is why I picked this project. I thought that this would be like a really good test case. There's going to be other stuff I do where it helps not at all and I won't bother with it. Okay. This is good. This is good. Oops. I don't know why it entered there. Let me go see if I can figure it out myself as well. Retain graph. Contiguous calls. We're going to test if that's actually the correct thing. Oops. If you don't mind, how's your take evolved since last stream? So the way that I was using Opus last stream, because I said I would listen to exactly what all of you said, was completely stupid. Like, do not do that. That is awful. Um, I'm using it now with way, way, way more control. I have pretty much the exact same amount of control I have as if I would be writing my code manually. I am mostly using it to avoid getting stuck messing with syntax across a ton of different libraries and languages, as well as to fix like setup and building jank. Um, I'm not outsourcing any of the control over design of control flow. So this is like way more using it as a tool rather than actually just replacing all conscious thought with it. This is actually quite nice. Last stream was the most depressing shit ever. Let's double check this is actually doing something. I have not started writing the article. I will write the article though. At the moment, we're doing another project with this. We're doing this is a kernel profiler. So we're writing good profiling code for all of Puffer 4's custom kernels, which is quite important. I figured that this would be a fun project to do with this. Okay, so let me use the restroom real quick, get another mug of tea, and then we will figure this out. And once we have this done, we'll clean up the design, and then we'll be able to very, very quickly do this for all of our kernels. And we will have a really nice kernel benchmark suite. And I mean, this is one of the key things that we need for understanding how we get Puffer to 10 mil steps per second. So, good project. I'll be right back. Okay. I'm having a good time with this. This is way, 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 way better experiment. Way better experiment. It's so funny to me that you have we had like 200 people watching the Code No Think stream, and then you get like 20 some odd watching actual good dev with effective use of tools that don't rot your brain. It's funny. Uh, okay, so this is a weird speed test. You guys see the issue here? So I literally commented out this backward pass. I don't think this is correct. Let's go look. So you call autograd.backward. What is the in the MMO crossover? Yeah. The MMO crossover, that got me good. I did frickin' reinstall RuneScape again. But hey, I this is actually gonna get me back some time this way. So it's cool. Honestly, like the thing is we're very close with Puffer to the point where I think we can just if I were to just have an environment for each pretty much any individual boss, I think we almost are the point where we can just one-shot it with RL. I mean like one-shot learning, right? Like you run one, and to be clear, that means you run one automatic hyperparam sweep with the default architecture, and it just solves. I'm pretty sure that we're just about to that point with Puffer. Um, and obviously, like a ton of my research was MMO inspired. There's so many good things in there for RL and AI in general. Oh yeah. Let me make sure I did this correct. Idea guys are good marketing. Yeah, exactly. Baby. Jabrim? That's fun. I didn't actually mention my own stuff on RS. I checked actually. So apparently I have about a 4.5 bill bank these days. I don't quite have all the gear, but I have most of it. So yeah, I actually can start testing out a bunch of the new bosses. And maybe I'll get some ideas for more RLMs. This is definitely research, yeah. Time to raid. The problem with the raids is like that's when you get into like just really long sessions, unless you're doing solos. I actually saw that Chambers is back to being worth doing, and that's like my favorite. I think that's my favorite piece of content in just about any game ever. And that's why I did the Ulm fight as the RL environment. I would like to finish that environment, though I don't know if I'm gonna like finish it with. It might be worth it for me to just go try to manually refactor that code to see how bad it actually is. We'll see. Yeah, so this is weird. Few gems. I mean, in general, I really like the idea of like, so MMO fights are an amazing way to showcase how stupidly good RL is mechanically, right? Because it's just like the devs making mechanically harder and harder fights, and RL is stupid good at that type of a thing. It's actually like doing a quest would be way harder for RL, right? So it's a kind of a nice way to showcase the strengths of the method, to get something cool, and then also as a test, right? Like these M's are also tests of the methods. What advice did you get? I mean, people just straight up don't want to think. It's nuts. Like they basically just want to tell the thing to solve everything and then fix the bugs, fix the bugs, fix the bugs, describe feature in English. Don't outsource your brain. That's awful. As it ends this profile, showing a little bit of field research going to the boss. Eh, that'd be fun. Horizon length. Well, Quest also gives you English descriptions of stuff, but like yes, horizon length. The way to think about it is you're actually sort of being told what to do, because you understand the visuals, right? Just naturally. So you understand, oh, if I cut this tree, I get experience in this thing, and then you can go read, oh, requirement for this thing is this level, and you have a lot of just understanding out of the box. But RL agents don't bring that knowledge to the environment, right? So it's not very self-contained, and the fights aren't self-contained either. But the thing is, they are actually brute forceable by trial and error plus good learning from that. I could go into more detail potentially, but like that's the gist of it, I suppose. Bot animation cancel a spell. Heh. Yeah. OpenAI 5 is way more impressive. Way, way, way more impressive. Yeah. That's the best result in the field. And that team was so good. Adding gradients. Interesting. I don't know if that's the correct thing. And lasting impacts on pro. Yeah. I mean, it's kind of tough to show you how hard, like, how ridiculously good RL is mechanically at stuff. This is why we are going to ultimately want some ends that are reminiscent of real games. Like, I don't know, actually having a full-on ohm fight would be really cool. I don't want it to be some vibe coded crap though. I wanted like actually make sure it's good and correct. 0 the gradients before each backward fall. Roller kernel doesn't do this. I don't think that's going to help, but we will try this. Cloud without brain. This is going way better. Hide your stats. I'm not going to put it in the actual game, dude. I don't want to bot their game. If anything, I'd way rather help them use it for bot detection somehow. Yeah, that'd be awesome. I'd be super down for that. I mean, RS is my most played game, and I mean, my PhD was directly inspired by it. That'd be sweet. Oh, okay. Interesting. Give it an NSYS report. Mod Ash is always untrue. Yeah. Well, I'd have to actually finish the end and maybe get my master's home back. Be a respectable player. Almost Hill 3. I was so annoyed when I couldn't freaking equip that thing yesterday. Run with the kernel uncommented. Really? ARPG style. Like I imagined. Fun. RL for Celeste. Ooh, very cool. Very cool. Like binding the game or re-implementing the game. The big problem with RL on real games is always just that they're just too slow. It's like almost always easier to just build a fast sim. Binding, alright, yeah. So the annoying thing with RL right now is like I've gotten Puffer to a point where Puffer actually works. Like you give it a fast sim, it actually just works. The quality of methods and lit for stuff in the lower sample regime is just way worse. Like there are a bunch of methods that claim that they work with very few samples. They're very slow and they're also very fiddly. And like the quality of the experiments dramatically overstates how good they are. So 2 days of training. Yeah, that's the thing. Like, I can guarantee you, clearing those early rooms, you'd have it training in 2 minutes with Puffer. This is why you build custom ends. Interesting. Oh yeah, this is silly. That's what I figured. Welcome, user. 1000x less step speed than what you have. Yeah. That's I mean, this is the whole thing I did with Puffer, right, man? Is I made RL 1000x faster. So you're basically stuck with pre-Puffer levels of perf. I mean, there are a couple nice things with Puffer, right? We do have some algorithmic improvements. And actually, we are expecting to have some sample efficiency improvements as well in Puffer 4. But, like, nowhere near 1000x. GPU trace. It's weird. Let's see if we can find anything from this profile. I wouldn't be surprised if this is just weird, some like weirdness with how we set up their profile. $220 device mem copies. When you return the saved tensors, it's copying them. Ugh. When you return the saved tensors, separate output tensors. Let me see. Oh, ironically, try this. That'd be really funny. You manage work-life balance. No, not every waking moment, but it is the major focus. It's more than just the job, you know? I think about it quite a lot. I mean, I work out, like, pretty hard. It's pretty hard to think about other stuff in the process of doing that. I get good sleep, I get food. I mean, the hours aren't even super crazy in my view right now. Like, I have blocks of work where I do crazy hours, but I'm not doing it constantly all year. Pretty simple to use. Yeah, I'm trying to make it even simpler. It's tough. Ah, perfect. I literally did this in order to try to make it like more. Okay, whatever. Torch is weird sometimes. Let's try with the kernel enabled. Even simpler, yeah. I mean, it's a balancing act in some ways. Respect to the discipline. Yeah. I just did like yesterday was my first. I guess it's on treadmill, so I don't know if you really count it. But it was my first sub 7 minute pace 5K. It's actually faster than my best high school time. And when I was in high school, I was like 35, 40 pounds lighter. So I've been trying to beat that that old time for a long while. I don't know if I could do it on road. I think I could do it on flat road if it's cold out. I probably could. And the strength work is good too. I've got about a 405 deadlift these days and a 2 plate bench for 5. I just started squatting again. I hadn't been doing that for like a year. That's going to take me a little bit of time to get some weight back on, but making progress. And then I got to get my shoulder fixed. I'm going to PT on Friday because I got this old injury and I want to see if I can get to be overhead pressing again. That was one of my favorite lifts. Okay, look at that. Now we have, this is on par, you see? On par. Give it a contiguous. Make sure that this is still on par. Sports, yeah. The gym I go to is like a really serious gym and they have some good people. I don't know actually what you would call it, but I don't know, we'll see. If I can just get this thing back working without needing some surgery, that would be awesome. I had a pretty decent overhead. I think it was like 165 or whatever. And I was training for like much heavier. I have all sorts of really awesome shoulder training equipment in the gym in Maryland. I'm not going to be doing dumbbell presses again with shoulder presses. That's how I heard it. Screw that. Honestly, the thing that feels best on it is probably like log press is my favorite. You know the neutral grip it has with that. All right, so this is now good. So the thing I need to understand is what the hell this is doing. Does it? Let me just double check. I'm pretty sure if I do this, it's now slow again, right? Yep, it is this. Cool. Very weird operation. I'm gonna make a commit on this actually after this. Hmm. Ew, okay, so this is what does. Alright, that's fine. Let me just go set all this up and I will have this. I like this way you're using more. Yeah, this is way better. I mean, honestly, the other stream I did just felt awful. That was just the worst thing ever. Okay. Oops. Clear this first, and we're good. Alright. So, let's take a look at the design of this. We have a 200 line profile. This is going to get the forward and backward pass for one kernel. And it's also going to get the torch versions with the torch wrappers. Let's go look around for redundancy and other stuff, yeah? Have a nice sip of tea first. Okay. We got our warm-up itters, we got our timing itters. Oh, we can't be lazy, we gotta actually read through and make sure I didn't make any mistakes. Okay, so lightweight CUDA event. We do device synchronize for the warm-up. But then we do... Is this not going to queue them in parallel? CUDA events measure... Okay, so they're on the same stream. Cool. Interesting. That is good then. That's very good. Okay. Let's take a look at this. So we have just a simple struct per kernel. Allocate this. We alloc batch seek. So we allocate everything. Yeah, we allocate everything. Free some intermediates, that's fine. I don't really like these run functions. I don't think there's a clean way around this though. And then the torch one is basically the same thing, but we need a tensor wrapper. You need new because these are tensors, fine. You don't allocate any memory. You just use this from blob thing. Run forward once to set up the outputs for backwards. You don't need this this comment. This is very obvious. Retain graph equal true. And I think honestly the only thing that's a bit jank is the printing at the end. Yeah, we'll just pull out the profiling prints. Yep, this is nice. I'm gonna move it a little bit, but other than that, it's fine. I like that. Why do it twice? Yeah, got the redundant one. Cool. Okay, so now we've got this. This, cool. Three, these are good args. be good. And let's see what our profile looks like. Yeah. This is nice, right? And ideally, we could do something a little better with this maybe, but okay. What's the test? So we've gotten everything that we need for this. It's not this one. We pretty much have everything. This is going to be a larger diff. But this is basically like template copy paste now. So we did a bunch of work to get this about as compact as we possibly can. We're still going to read through it though very carefully. So it's your arc tensor. The names we're going to have to refactor at some point. That'll be easy though. Okay, so we get some Alex. The raw launch, and then here's your Mingru 1. Okay, needs to add this. And then it's also going to need the profile, right? Which is right here. A little simpler. Good. Okay. Now we have extra 100 lines-ish. I don't like where it put this though. So I'm gonna rearrange a little bit. I like pretty much everything except where it put this. You always group all the code for this one thing together. You never group like all the functions of one type and then all the functions of another type. This is much, much better. Now, I think I messed up. Did I mess up this end if? I think I messed up the end if a little bit. Let's go look. Okay, this just has an internal one. If. It's because it wants to put everything in one. It wants to put everything in one torch function, I see. So we're gonna have to fix that a little bit. It's funny that it wants to do that. So let me see. Do we trust it to reorder things? Let's actually just go see. And then we'll test the mid-brew gate. And we have, I think, 2 or 3 more to port. We do have to read all of this. I'm just like looking to see if it broke anything in the process. I don't think so. It added some silly comments. It's the same spacing, didn't add any dumb other comments. This is good. This is actually quite good. Okay, you don't need to have main here, my guy. Let's go see. I absolutely hate how it has this like indicator that's like vibing, clodding, spelunking, and then all their ads are like, don't think. Whoa. It could so easily give us a little bit like a one line of what it's actually looking at. Month since he didn't make a change through Claude Code. Since he didn't make a change through Claude Code. Isn't this the UV guy? That's weird as fuck. Yikes. What are we doing today? Kernel benchmark. Don't need this. These. Nice. Now we have 303 lines for 2 kernels. And the rest of these are like basically automated. But it's very important that we have this structure the way that we have this set up and we have everything shared the way it is. Because your profiling code has to be correct, right? Like the worst thing ever is when you have wrong profiling code. Very good. How using Cloud Code without brain damage? I'm using it with much, much more precise control over everything. There's no vibing here. This is just like pretty much the whole setup of all this. Every single bit of this was done precisely. I wrote. I'm mostly using this to fill in syntax, frankly, and then also to do like these fuzzy sort of copies and this fuzzy porting. Like here, we just spent what, 2+ hours getting, no, like 3 hours, I think, getting this done for the first kernel and being very precise over the structure of this. And now as a result, we can probably have it just port the next kernels in the exact same format. But if I'd let it come up with the structure of this test, it would have been a mess. Yeah, I definitely did more work, Robin, than if I weren't using it. Absolutely. But the thing is, like, if I were doing this the way we're doing it yesterday, the other time, I would have gotten negative work done. Right? If I just turned my brain off and tried to do this, like, the product of this would be worse than not having anything. It's way better. Yeah, I basically, so I said that I would do a stream, right, where I just use the LLMs the exact way that chat says, because everyone's saying, oh, the models are so good. And of course, I mean, everybody recommends the most brain damage possible way to use the models. And oh, there's a skill to using them. It's all bullshit. Like, the only skill involved here is actual programming skill. Has nothing to do with what I'm prompting or bullshit, right? It's just like me deciding on, like me coming up with the structure of the tests. And you can look back through the VOD and see how much I did manually. There was like, it's actually, I really like this now because this helps me spend less time on the worst part of my job, which is essentially just here. This thing right now, I have CUDA syntax, I have C++ syntax from libtorch, I have libtorch's shenanigans, I have mismatch between CUDA streams from Torch and CUDA streams from, raw CUDA, obviously, C10. I've got Python binds to deal with. I've got like memory bindings from CUDA into Torch. There's a ton of stuff that all has weird and very poorly documented syntax. So this essentially prevented me from having to spend hours bullshitting with that. And I mostly spent my time today figuring out how to get clean tests that will work across both Torch and raw CUDA into one file that are fast and are minimal and will allow me to add several more kernels in without making a total mess. Mm-hmm. And this code is like, this is exactly the code that I would write myself as well. So way better. Right, we don't need this RMS norm kernel because this thing doesn't even work anyways. Log coefs. I believe it is the... Oh, log cum sum exp is really easy, right? Oh, but that one does that even have a launch? No, we'll do fuse scan. Hmm. Yeah, I definitely think that if I just like said write a kernel test for this thing which lives here using this thing that lives here, it would have given me something that I would just not be happy including in my code base. But because, right, because we spent 2 to 3 hours coming up with a nice way to do this, and I basically what I did here is I ported the structure from my Python kernel test, and I had to figure out a few things that were language specific because C, C++. And then we tested everything, we cleaned everything up, and now when this ports it, it'll port it exactly the same, right? It copies the style perfectly. So this is much better. I don't love the D-type mismatch here, but I think this is okay. Okay. Freeze launches. And this gives us one-liner. And here's the forward and torch. The forward and backward and torch. Here's our profile. This is identical. Here's our torch profile, and here's our current profile, and this is good. What's different? So today I'm thinking as much as if I were programming normally. Like, because this is actually, if you're just joining now this looks like, oh look, he's still getting huge swaths of code from Claude, but the difference is, right, this is essentially, this is applying a template, right? I needed to have a kernel level profile that works for raw CUDA as well as for Torch in the same file. And we spent 3 hours on the first kernel, coming up with a good way to do that profiling operation that is correct and succinct and will be compatible with both and not mess up anything. We fixed a few things with the kernels to enable us to do that. And now I'm basically just having it port the other kernels over, matching the style, like this exact template, right? And then throughout, I was using it to cover syntax gaps, to run some of the existing tests, a few other things. But I didn't actually have it design any of this, right? Like at the function level, I am still implementing this. I still came up with, okay, we're going to do memory allocation in CUDA, and then we're going to bind that. Those pointers are going to go to Torch. We're going to allocate, we're going to fill buffers this way. So basically every single part of this is my design. There's really not more than a line or two anywhere that I didn't like do myself. I don't even know if there is that. Okay, and then what is this? Isn't this what we just reviewed? Yes, this is what we just reviewed. Let me add box. Cool. Now what do we have? Now we've got our same 424 lines. I think that there are going to be certain situations where this is good and certain situations where this is not super helpful, right? The thing that I like about this at the moment is like, I can definitely see this encouraging you to be lazier about the number of interfaces and things that you have to deal with because it makes it easier. Um, like, for instance, Opus would have less value here if I weren't dealing with so many different annoying language syntaxes and divergent APIs and things like that. But in this case, it's not like if I don't use Opus, I'd work hard to find a way around it. There just isn't a way around it. It's just I need to have Torch, and there's CUDA, and there's C, and there's C++, and there are Python binds. Like, this is already basically minimized complexity. So I think this is chill. Cool, and now we have a nice fast test. Interesting that this is it's a weird difference. It's a very quick test, so it's a very, very quick test. So probably we need to apply some more itters. No biggie. Next one to port. Perfect. How did I enjoy the chat? This is on X, Twitch, and YouTube. Be right back. Let me use the restroom, and we will check on this port. Okay. Scan arg, here's our tensor, or our struct. Okay, it takes all the args explicitly, so that's fine. CUDA malloc, all the stuff. That's kind of funny. It's actually nice that it did this. I think we'll keep this. This is nice. I'll double check this numerically, but this is nice. This thing still doesn't have numerics checks, to be fair. We should probably have that. But since I forgot, we'll just continue this, and I think it should be pretty easy to add them anyways. Scan backward, forward. Good. And let's copy this exactly. Exactly and exactly. Perfect. So this is just a exact port. Same thing as before. There's only one more of these kernels that we really need. Why meta able? I don't know about getting top hires. I'd say that's probably the reason, is they are not really. Okay, let's see. Okay, we got our scan. This is 566 lines now. This will simply have to be a fairly chunky test, right? There's no way around that. Very nice, very nice, very nice. Cool. Last one we need is the PPO loss. I'm actually curious. Okay, so the microbench one, this version is way shorter, right? 264 lines. Way shorter. The trade-off is that you're way more dependent on Torch here, right? Like here we're using Torch for all the tests, and here we have standalone CUDA, which is really nice. I kind of want to, wherever I can, I kind of want to make Puffer a little less and less dependent on Torch as I can over time. In case we ever actually get a good low-level library that we can just bind it to. Okay, so this one is massive. Massive. Ooh, what is this? This does not look good to me. This is why we read. Let me go through the rest of it first. Okay, so this stuff is fine. This looks super verbose, but this is just because it's a massive function, okay? Yeah, so the only thing that's super weird is this thing right here. Like, what is this? Saved row, saved for backward. Okay, so we actually do have that. That's fine then. Yeah, it actually is just like that. Square. See, this is a little odd. I do think this is the least important kernel, though. I do think this is the least important of the kernels. Yeah, this is just janky how I have it structured. So I think in order to change this test, we'll have to change the kernel, which is not going to be worth doing until we assess the speed to see if this kernel is even really worth having. Because this is also the only one that's numerically janky, I know. So I'm going to just take this change. But if we do keep if we do end up keeping this kernel, this test is not going to look like this. Okay, so now we have giant. That was like half of the. Oh no, wait, that was not. All right, so 300 lines. It's fine. 800 line, 800 line test. Okay. 800 line test. Okay, so you can see this kernel is like tiny, right? Yeah, this kernel is tiny, even with hmm. Well, I guess we don't have yeah, we don't have the raw torch comparison, I suppose, right? We just have the kernels. Yeah, so there's still a number of different things we need to add here to these comparisons to know which are important and which are not. These are reporting billions of elements per second, though, which is a little odd. Let's go take a look at compare. Not really 24, not at all. Okay, the backward check is off on this log coefs. Should probably just rebuild just to be sure. I remember I messed with this kernel before. Hmm, that's funny. Okay. So our tests are massively different here, right? This is reporting billions. So we have a nice test, but I'm actually, yeah, I would think there's no way that these are at billions. 32 by 1024 by 2048. Let's go take a look at these. Take this here, put this over here. Batch sequence, what is it? Batch sequence and actions, right? And what is this for like fused? Batch sequence actions. Batch sequence hidden. Yeah, that's weird, right? Okay. So batch should be, first of all, Can we not have this thing like... Okay, good. Int B. Well, then let's go check over here. A equals 4. Yeah, so because PPO loss takes A, so, and where's fuse scan? Log cum sum x, which is B, T, and H. Fused scan is B, ET plus 1, H, log constant values, PTH, cool. Let's go see if this changes stuff. Okay, so we still have crazy numbers. Yeah, we still have crazy numbers. Where were our... Oh, what's this? Okay, we'll try this one. Batch. Let's see if we're getting a weird multiple in here somewhere. Like, I think, was it min-grow gate? This should be the easiest one to make correct, right? Min-grow gate. Okay, args n. What is n? Ah, see, so args n is wrong. Yeah, this is the profiling. The profiling is just multiplying by 128 or whatever. Yeah, it'll match actually quite closely. Cool. Am I still doing research at MIT? No. I graduated, I finished my PhD 2 years ago, roughly. I'm working on Puffer full-time. Currently, I'm working on benchmarking our custom kernels for the 4.0 release. Does this workflow beat Supermaven? It depends. So I wouldn't want to do this with everything. There are definitely going to be things that's just going to be way better to write fully myself. Well, I still like Supermaven for um like dumb tab complete saves typing. This is kind of one level above that. Um, the thing is, I chose a really good task for this today, okay? Because this is, here we have CUDA, C, Python, and C++, as well as the CUDA API. We've got the Torch CUDA API. We've got timings to deal with. We've got like a bunch of memory sharing between CUDA and Torch. Like there's just a bunch of API jank, right? And it's very strongly verifiable. And I already have a version that I wrote myself in Python. And it basically, this needed 3 hours worth of me sitting down and figuring out how to write the profiler for one kernel. And then this thing is very quickly able to like use that as a template to port the rest of the kernels in a way that's perfectly verifiable. So it's a combination of this being a way lighter way to use it that really saves more typing than thinking, and this also just being a very well-suited task. What are your peers from MIT doing? I don't know, join companies. Some start companies, whatever. Okay, so actually, this now we can actually have Claude fix this thing, right? Puffer work is something like that task. I don't know. I guess we'll find out, right? I think that this can save me a substantial amount of time, provided that the way I'm using it is not producing like worse code or substantially different code than if I would write it myself. It's very slow at the moment. I think the main thing I have is that it's quite slow. Um, it's still faster than me typing it for sure, for most of the time. No small fixes. All right. Okay, I like that. Now let's see if our profiles look more reasonable. Experience until now. Today has been very good. I mean, it's a night and day difference though. Like, the last stream was just the most depressing shit imaginable. I went directly from there to 4 margaritas with dinner. Today is quite chill. Like, I'm having to actually think. I'm tired. I'm thinking probably about the same amount as I would normally. I'm not dealing with the same amount of bullshit I would deal with normally, which is nice. I'm definitely getting more done. And the quality of the work I'm doing is on par with my normal at the very least. I don't know if I'd say at the very least. I probably wouldn't build this profiler like normally, even though I know that I should have a profiler like this, because the amount of time that it would take to maintain it by hand would be such a pain in the ass. But this is one of those cases where you do just kind of need something that's going to just be a bit longer, and there's not much of a good way around it. I'd probably stick, if I didn't have this, I'd probably have to stick to my torch profiler in Python, and that's just nowhere near as good. So I actually rather like this. Okay, so 2.28, yeah, this is correct, right? I mean, that's trivial. But I'm kind of thinking about, in the meantime, these numbers. No match up yet. Hmm. Well, there's quite a bit left to do, perhaps. This is fine. MIT looking to do research. I would recommend joining a research lab. Go talk to professors, and when they don't want to talk to you, or when they don't reply to your emails, go talk to their grad students instead, and like try to be useful. Yeah, let's see what this profile looks like. I think we're still off, but some of them match. Some of them match. Good starting point for sure. Been live for 4.5 hours. Okay. Solid. So, in native, we get 2.29 billion. Log coefficient values. I'm trying to figure out why this would be so far off. Because I can totally just have Claude go look for reporting discrepancies while I use the restroom. Yeah. I'll be right back. Ugh. I'm out of 1 second. Let's go try something. Um, 10x the timing iterations. Oops. That might help. I'd be surprised if it's just the warm-up hitters. Be weird. We have other stuff that we need to check, though. Ooh, that does change it a lot. That actually changes it a lot. Let's see. 2.29. Okay, log coefficient values is still very different. Very different. Log cum sum x. Actually, this matches now, right? This is showing our kernel is worse. This is weird. Oh yeah, because we don't care about that opta. That's fine. And now, if you scan, still way off. Numbers are still way off. Okay. Microseconds. Do 10K hitters? Yeah, okay, so stuff still doesn't match, but we'll figure it out. Now, other than that, what else do we have to do? So we have to time. We still have to test correctness, and we also have to time versus the native C++. Let me think where this slots in for us. Look at this one. Okay, so we pretty much just need to add well, we need a couple outputs, don't we? Out log coast and vowels. Torch. Oh, you know one thing I do want to check. Do we ever have a substantial difference? We do actually, right? So I do think it's useful to have this overhead check. Yeah, we do need this overhead check, right? Yeah, because stuff like this, look, you see that there's actually substantial overhead. So that's important to know. Okay. This is where I have to be this is where I have to be careful, right? Because I've been streaming for 4 hours 40 minutes, and it's very easy to get lazy here and to tell Claude to just do too much stuff. Okay. I think I know what we want to do. So first, this might mess up with the auto compact. We'll see. It just has to extract some functions. We're going to take ops very slowly, very carefully. So I can't get lazy. Good. Right. So let's go make sure that these are correct. Very important kernel. Tensor list. Get the fuse scan op. Okay, and then we have the much longer. Good. This is fine. What parts of the puffer algorithm are original? So, well, it's a few things. There's this prioritized replay thing that we do for on-call. There's a custom advantage function. What the heck else? The Puffer 4 has a new architecture that's not in Puffer 3. What else? We have an article on it. I remember. Oh yeah. Use muon. That was the result of our extensive experiments, is that this is dramatically worth it in RL. Yeah, trajectory segment filtering, puffer advantage, and then there's the prioritized replay. So a number of different things. Some details here. It's not V-trace, no. It's a strict generalization of JE and V-trace together. V-trace alone is absolutely awful. JE alone is almost the same as ours, but ours is a bit more stable. It's a strict generalization of those two methods. It's actually very close to retrace, as it turns out, but developed for on-call. Actually, I'm happy with that because it's not going to mess with. That's totally fine then. I think if I want to move these into somewhere, do that in a bit. Opus episode 2, dramatically better, Tim. Dramatically better. I think what we do next. Used it to write a paper. What? Oh, for LaTeX and stuff. If you're using it to write paragraphs, well, I think I'd actually excuse you for that because the thing is, papers are bullshit anyways. Every goddamn time in my PhD that I would actually put the effort in to write a paper I was proud of, it would get rejected. My best cycle in my PhD was when I wrote 3 papers in 3 days in the dumbest way possible, and they all got accepted. So, I'd say don't use it for writing, but academic writing is bullshit anyways, so fair play. Derivatives. Hmm. Wait, thoughts on Sokoban observations. Walls agent. 4 by 10 by 10. Yeah, so Tim, chuck that. If you're using a conv, chuck that one hot into just a linear encoder just to make sure that you don't have dumb conv shapes. That would be my suggestion. That's a sanity. Hang on, guys. Let me think of a clean way that I want to integrate this test. We need to, wait, do we need to do this? We do. We'll try that. Linear layer after embedding doesn't make sense. Linear, you mean just put linear? No, just don't use a conv. Replace the conv for it. What do you mean a linear layer after embedding doesn't make sense? It's not an embedding, it's a one-hot encoding. It's one-hot, flattened, linear. It's not an embedding layer. You would never use an embedding layer here. You can go try it yourself. You'll see that an embedding layer is like ludicrously slow. And yes, I know it's just a lookup. It's still very slow. Standard linear. Did you try standard linear um on the one hot representation though? Okay, I'll accept this for now. It's fine. Why is it slow? Well, what dimension are you gonna embed it to, man? Because like you have 4. It's a one hot of 4. If you embed it to 32, now you have 10 by 10 by 32, which is big. Standard linear is just default. Default with LSTM, yes. I'd be surprised if you need more reward shape. Are you training, Tim, have you looked at like our maze environment, like which is grid? Like, are you sampling different sized levels reasonably and whatnot? Default pop. No, mingru is puffer 4. There's no mingru in puffer 3. It's actually kind of funny because it's not going to even be standard mingru in puffer 4. I came up with a major improvement to it. Yeah, take a look at grid. So pretty much we make a bunch of levels of different sizes and we cycle through those. Random level, but is it random of variable difficulty or is it like all about the same? Like you need some easy levels. No middle walls. That might not be smooth enough. Like it might just go from easy to hard, right? I would want variable size, but I guess what you're doing is you're giving it like global obs or something. In grid, what we do is we give it localized observations. So we can use variable size maps. It's pretty good. is hard and sample. Yes, it's curriculum learning. We have some stuff on that. It's kind of tricky. The thing is, we could devote more time to that, but there's something that we're going to be doing in Puffer 5 anyways that will just be better than any form of that you could possibly imagine. So there's not a huge incentive to do so. Hey, there we go. Boom. Look at that. Look at that. Look at that dude. Local obs, just 5 run. Yeah, 5 by 5. I think we use 11 by 11. 5 by 5 would be faster, but you don't want to make it use its memory too much for everything, right? All right, this works. 1 box, 1 target, no walls. Wait, is it not solving the super basic task, Tim? It should definitely, like, it should insta-solve super basic task. Like, insta-solve. Like, for simple environments, Puffer one-shots them. Diffusion model RL, they're literally doing evolutionary strategies. Pfft, lol. That's funny. Okay, what do we got? I gotta not get lazy. This is just a copy. None of solving that. Yeah, Tim, so Puffer's like simple ends. If Puffer doesn't solve and you did some amount of hyperparam tuning, if you like at least ran a basic sweep, your end is wrong. Like Puffer's just like good. Gotta feed the puff. Oh yeah, speaking of which, for anybody who's new around here, please feed the Puffer. Puffer's preferred cuisine is stars. We have 4.9 thousand stars on GitHub. The Puffer would be very happy with 5,000 stars, so please go ahead and star the Puffer. That would help. It's free. What you're watching me develop will become the fastest open source RL library out there by a huge order of, well, not an order of magnitude, but close to it. We're going to target 10 million steps per second in this release, so if you like doing RL on your laptop at home without needing a massive cluster and still being able to do cool shit, this is the place. This is why I'm spending so much time on kernels. TLDR, what is your setup? Hey, Jeff. Um, it's pretty much just like me actually having control over everything and using this to save me a lot of typing and not letting it make any design decisions and nitpicking everything. It looks very different from the other day. This is producing like the same code that I would write by hand now because I'm forcing it to. It's a So here's the thing with different accelerator backends. Everybody's being real stupid at the moment with those. For some reason, the conclusion has been that in order to support different accelerators, you need to write everything in Python. So I'm not messing with that. I'm just going to write CUDA because this is what I have. Like, TPUs don't have a low-level interface that I'm aware of. It's all jacks. I'm definitely not doing, like, niche other random companies. So, eventually, I hope that there will be some CUDA-like language that's about that level that just compiles to everything. And the assumption that's baked into that is that the different accelerators will converge to a similar architecture, which would make that possible, if that makes sense to you. Yeah, compiling Torch Python to Jax Python is bleh. TensorStorm is C++? Oh, cool. Um, it's still a small company that just has some chips, right? Like, excellent. Very much recommended. Very readable. What's the code look like? Is this not meant to be human readable? What is it? I didn't know that there was actually. Is there actually a human readable language? It's readable. Where's example code? The fuck? Yeah, I figured you were. Razor that you just plug in. Wait, with like Razor the gaming company? That's cool. I have a bajillion Razor things, so the camera, the mic, the headset, the laptop, freaking keyboard, mouse. I got all the Razor things. I can't recommend their laptops, unfortunately. They are very, very nice, but they don't actually work. Okay. Okay, on one hand, this profile is just massive. On the other hand, this is not massive because I've been lazy. I think this is just genuinely the amount of code that this takes. I don't think if I thought about how to do this shorter for a couple days, I could do much better. In fact, I think I'd probably make it shorter but more complicated and ultimately worse. So I think that this is good. I will build it myself, thank you very much. Questions from someone? Stop around 5 to 6. Yeah. What's up with questions, Convert? Because it's using my stuff as a reference E10. Well, if people have questions like this, just come ask, right? I'm streaming, right? I don't have to get off stream and then answer questions. Okay, so I don't know if this matches our other profiles, but at the very least, it's self-consistent, right? That's really good. How big is this stupid file? Still under 1,000. Still under 1,000. Get rid of this bot. Okay, so I have to think a little bit about. There are a couple consistency checks I need. Couple consistency checks. Threads, kernel shapes. Yeah. I mean, these are custom kernels though, right? So there's, I think, one more major feature this thing needs, and then we need to make sure everything's consistent and nice. A lot of auto-tuning people use. Yeah. So the problem with the auto-tuning thing is like, it's not really a good way for me to do it standalone as far as I'm aware. It's kind of all wrapped into bigger stuff. Hey, now that I have this benchmark, it'll be substantially easier, right, for me to play with. How much does each thread do? Wait, what? To play around with threads? Yeah, those are just launch args, dude. I have custom kernels, so obviously I have to specify all of that. Let me use the restroom real quick. You replace the GPU, it might not be. Yeah, that is true. These are very light operations, though. Like, it's kind of a different regime than normal. I could try it on different GPUs to see, but like, I definitely need to have this script be better to make it easier to do that. You could make each thread do more work. Yeah, but like, there's not that much total work, is the thing. These are very small kernels, right? Like, these are tens of microsecond kernels. I'll be right back. I'm in the restroom. I'm gonna grab a drink. I'm gonna walk around a minute, and then we're going to figure out. I don't know if I add CUDA support to this thing yet, or whether I do or whether I go double check this versus the other profiles. We'll see. But this is gonna end up being about 1,000 lines for these 5 kernels, so not terrible. I'll be right back. Ugh. is it? 3, 4. Okay, cool. I'll be right back. Okay. We need one more feature, and then we need to make sure everything's correct. Working a biped place and is wondering about proximate SPS. About as fast as you can run the thing. About as fast as you can run the thing, probably. Like as fast as you can run the sim. Guess for a good SPS. Simple, millions. You finish cutting? Yeah. But on my work days, I just don't eat during the day, so eh. Oh, you know why I'm starving? I forgot to make myself. God damn it, that's why I'm starving today. I normally make myself like a ridiculously heavy protein drink in the morning, and I forgot to make it today. Okay. The only other feature this thing needs is coup de graphing. We don't need to coup de graph. We only need to coup de graph the C++ one as well. See, this is where it's getting to the time of the day where I'm really tired and it's very tempting to let Claude do too much. We're not going to do that. Instead, I'm going to make a quick commit. Okay, now we have this. Okay. What we need here is extensions. Let me go look at my coup de graphing. We already have this nice little capture graph function. Yeah. Okay, so this is going to be capture. It might be tough to capture the backward graph, right? Start with it on only one of them. Gate grad hidden. We can use the same one, I think. Create log code from value. C++ outputs. You know what? I think when we test this, okay. Now, That'll simplify so we don't end up with a bajillion of these when we go to do the graphs. It'll actually make it quite easy. So hungry. Yeah, how much have we used on this balance? I'm a little bit confused what happened, to be honest, because it said that I'd used way more credits, and then I looked back and it's like refunded me some. So I actually don't know how expensive this thing is. Whatever. Uh, to check this. So yes, yes. Ooh, I didn't even realize you could do. Yeah, yeah, you can merge those functions. That's nice. Try that. Well, I'm not using it that way, dude. Have you seen the stream? I don't know how long you've been here. Not losing brain cells today. Just joined. Watching 2x speed later. So, today I spent like 3 hours designing the profile interface. I'd already spent many hours before that doing it in Python, but redesigning it in C++ to be compatible with raw CUDA as well as torch binds. I used Claude to help with syntax on that, and then basically to apply that as a template to all the functions I've been porting. So this is mostly saving me a massive amount of typing and fixing minor syntax bugs. It's not really doing anything higher level. It's not even making like any lower level decisions that impact perf at all. So this is like way, way, way more control. It's producing, another way of looking at it is I'm producing the same code with it that I'd be writing by hand. Okay, cool. Let's try. Let's see what this does. Eighteen 25, 150, 184. Cool, exact same. So that's just merging together. I made one very minor error. Not even an error. I didn't realize I was doing one redundant thing. So this will actually save us some lines. Or torch. Oh, where'd it go? All right, let's make sure it does it correctly though. out. And then the last thing I want to have done today is I'd like to have coup de grace applied to this. This is what you want. Not exactly, Steve. The last stream that I did was the most depressing shit imaginable. This is completely different. Yeah, so this is redundant. Same pattern. Yes. Yeah, the LLMs are better than expected, much better. It's the usage pattern was the thing that was just utter crap. To be fair, the thing that I'm doing right now is like, I kind of picked the best possible scenario for it as well. Because this is like unavoidable syntax hell of 3 or 4 different languages and a bunch of different libraries. Okay, let's try. Make sure that this is here. And then is this 880 lines? I think we saved like 50-ish. So then I should be able to have about 100-ish for about 1,000 lines for this full test. Okay. Hmm. Right, this is the bad kernel that I didn't bother with. Everything else matches what we'd expect, right? Yes. Cool. So now, last feature we need to add is coup de grace support. Yes, of course, Steve. But I'll tell you what, I sure as hell don't have incentive to hire fresh grads that were using Opus in the way that I did last stream. Like, if that's what you're doing, you genuinely should have gone to trade school. Like, you'd be much happier and you would actually have a job. Um, like, you have to think. Like, if you're using a tool to replace your need to think, then you're just in the wrong line of work. 1 plus X for productivity. It's going to be heavily, heavily task dependent, man. The thing is, like, it's hard to even give that because I wouldn't have written this test if I had to do it by hand, right? I would have done something slightly worse that I could have done quicker in a day or two. Like, there are going to be several things for which it's going to be like zero increase, right? It's just not going to help at all. And then there are some things where it's going to be like 2 or 3x, maybe a little more. The thing that's more important to me, though, than like a raw productivity multiplier is that now instead of using this to try to automate thinking, I'm using this to now automate the most bullshit parts of work, which are dealing with tons of stupid syntax from a ton of stupid libraries and a ton of stupid languages, as well as like fuzzy application of the same pattern to a ton of code. Or just vibe coding their homework now. Yeah, if you're doing that, you shouldn't be in university for CS. Like, just literally go learn to weld. You will be happier. Yeah, definitely a win. And this is a very valuable test. Like, what I'm writing here, this is a very, very important file for Puffer 4, because this is what is going to tell us exactly how fast all of our kernels are and how important each of them is. So, very important file. I am getting tired though, so I can't do this for much longer. Um, and I don't want to like screw up and let Opus do too much, right? So. I want to make sure I do this smart. Hey, Ryan. Oh man, what? How the hell do we have? Wait, was this? Where's plot? Yeah, I have it here. It's the other one. Okay, hours. Suggest you do multiple. No, I don't need multiples. Oh, hey Ryan, I've been catching stream, but VS put 1 to 4 line. ChatGPT for standalone scripts. Do you think Cloud Code was useful for larger changes? It's definitely useful, but you don't want to let it do too much. I'm giving it very isolated changes and very little authority over control flow, design, or anything. It's pretty much saving me typing and saving me from screwing up syntax with a whole bunch of different libraries. There are definitely things for which it would not really be that helpful at all, but then this thing that I've chosen to do today is pretty much the best case scenario for it. Human reason is useful. That's just such a repugnant view to me, dude. I don't know what the hell's wrong with you. Like, actually go touch grass, man. These models should not be giving you depression. Have you found that takes less time to describe the problem? No, I'm not doing it that way, man. That's the thing. I did a stream, so I did one stream that was just vibe coding crap, exactly the way that chat told me. It was the most horrible, depressing, dehumanizing shit I have ever done. It was awful. Do not do that crap. All right, and now I'm not doing that anymore, right? I'm basically I spent 3 hours today setting up very carefully, like exactly how I wanted a profile to be, using it to fill in bits of syntax. And now I'm essentially using this as a template and having it apply this template to a bunch of different kernels. So it's like the ideal case where you have CUDA, C++, Python, and C, as well as TorchLib, CUDA, and then the graph APIs for both of those. So you got a bunch of syntax crap around, right? And you have a pretty regularly defined pattern where I've already written all of the logic out for all of this, and I've already compactified it and made sure that everything is nice and clean. The average CS grad should have been worried way before this, man. The average CS grad wasn't doing anything before these models came out anyways. Probably would have had to reference a bunch of docs. Yeah, the docs are like bad. Um, Here, I can show you the type of thing, man. Look, like, so like if I just told it to write a profiler, it wouldn't have structured it like this at all. So I came up with, okay, we're gonna have this struct, which is gonna have raw data in here. We're gonna do all of our allocations as raw CUDA Alex here. We're gonna set data like this. We're gonna copy it over. We're gonna get rid of buffers. So this whole structure, this was the initial function that I did. Okay, and then I said, okay, so now what we're gonna do, yeah, we have our freeze, whatever. We have our run function wrappers that are gonna launch it. It's going to take a pointer to that struct. This was my design as well. And then in Torch, we're going to have another struct that is the same thing but has Torch tensors. This is what I came up with. And then we're going to use the data pointers from the CUDA allocations instead of using Torch's allocations. This was mine as well. It's going to still have a struct pointer like this. We still have the same run functions for Torch. And then the profiler is going to use a single profile function that takes this kernel function, which is just like a one arg function, like void star basically. This was my design as well. And then we're going to have under a macro guard, we're going to have the Torch version here, which just does the exact same thing. Like this was all my design, right? And then I have 5 kernels that are like this. So like you can see there's not really a shorter way to write this code here, This is like a couple hundred lines of code, and I have 5 of these kernels. You see? That's a lot of code. And it's like, you know me, I will write shorter code if I can write shorter code. This is one of the cases where like the simplest solution is genuinely just quite long. Now we're gonna add coup de graph support. Did it do 4 or 5 of them? I used it. I used it the whole way through, but it's the question is how did I use it, right? So I already had. I wrote this a while ago. So I gave it this because I wrote this. So I already have this test in Python. So then I came up with the design of this for C++, right? And bit by bit, I had to implement chunks of things for one kernel. And I edited stuff a bunch and I redesigned stuff a bunch until I got it nice and compact. I also gave it, where is it? We have my kernels. I had to change some stuff here. Yeah, I had to change some stuff with the launches here to make this work. I gave it reference to modules. So it pretty much has the exact thing that it needs already in like different languages and with slightly different design. I guess the ultimate thing to think about here is just like, I use this to write the same code that I would have written faster. This is not it writing different code than I would have written. I didn't say like go write a profiler. I didn't say like, here are some guidelines for how to write a profile or go do it like right. I had pretty precise control over the whole thing. Plan mode, it keeps tabbing out of that. I sometimes remember to tab it back in. But then it's just as good if it just proposes something bad, I just like, correct it anyways. Similar to how I've tried to use in the past, better interface, probably better model. Yeah, now the one thing I will say is the way that it's advertised and the a lot of how it's like intended to be like this is the totally wrong interface for actually thinking, right? So it very actively pushes you towards not thinking. Like this shit should not live in another terminal. Like this shit should live in my editor, and it should be like it should probably be doing stuff, like as I'm typing here. It does. You don't need a different IDE for it either. It's a very, very bad form factor essentially uh, for maintaining independent thought. So you do have to be quite disciplined about it. Like you cannot just outsource your thinking to this stupid thing. I'm very happy with the result of this. Like the difference is the thing that I did on the other day. I basically had no ownership, control, or investment in like the actual outcome, only in the result of it. Like I didn't have any investment in the code itself, only in the result. Here, it's writing the exact same code that I would write normally. No, I'm not telling it to. I'm not telling it to go propose a plan. I'm not doing that anymore. I don't need it to propose a plan for the thing. I know how to do it, right? No, I'm not doing it that way, E10. I'm not doing it that way. You cannot turn your thinking into a purely discriminative process. That is lobotomizing yourself. It produced and seemed pretty miserable. Yeah. So it's rough. I would not I literally I went straight from that stream to dinner and had 4 margaritas. it actually took me several hours to process and internalize that actually I don't hate these models, I hate the users and the developers, to be fair, for like making it in such a form factor that discourages thinking. But you can actually use these in a way that supports your own, like that actually supports you, and allows you to have full control and allows you to learn the exact same amount that you would learn if you were writing manually. And it will be faster on some tasks by a lot and not by very much, if at all, on others. Oh, also, people saying that there was like some skill in using these are just straight up delusional. There's like actually no skill whatsoever involved in using these tools. Um, the only thing that comes into account is skill as a programmer, and you take that out of the equation if you just vibe everything. So you have to maintain authorship and control. It's, yeah, I really don't actually like big autocompletes while I'm typing. Name collision's good. Ryan, I actually wish I could disable multi-line complete in a Super Maven. I never want it to complete multiple lines. Want it for filling out Dix instructs. Yeah, see, I'd rather just have it be single line tab for that. Because otherwise it tries to multi-line tab too much stuff. The difference, Ryan, is that Super Maven is so fast that if you wanted to fill out a struct and have it be several lines, you just go tab, 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 tab. It has like, 100 ms delay, which is why I want it like super fast models for autocomplete. Definitely what you want. Right, so this does need to be behind this guard, which is annoying. I kind of forgot about that. Yeah, I sort of forgot about that. Okay, I don't like that. Let me think. Coup de grace for play. Yeah, no, that's real bad. Um, hmm. Let me think how we do this reasonably. So the annoying thing here, right, is like this looks almost identical, but we need to conditionally include torch, and it's a torch coup de grace. It's not a raw coup de grace as well. Yeah. Oh, and this bug is lovely as well that it flickers. Graph. Yeah, this is way better, right? Let me go double check this versus my version. Coup de grace. Tools didn't support. Yeah. I mean, but the thing is, like, in this case, you don't actually hate the tools, you just hate the people. Okay. That's fine. Good at math and physics. You know, I started taking more math heavy stuff in ML and it just wasn't useful. So I ended up doing a whole bunch more. I ended up spending most of my time just doing research and engineering in general. It was a way better fit with how I approach problems. Yes, this is needed here. And this is the additional profile graph. Profile graph with this function. Yeah, this is fine. Then if this works, if this actually works, then I can get it to like apply that as a template to the rest of them very easily. It's the same exact code. And then I pretty much just have to go check this versus the ref. Because I think there's some timing issues, some discrepancies, and probably clean up some names. ML as a whole does need math. And it's not just stats, there's a hell of a lot of linear algebra. But that doesn't mean that everybody in ML needs to be. There are a heck of a lot of ways to make progress, and in my case, it was mostly Eng. Okay. Yeah, so we fixed this before. Yeah, this is way better bitwise. This is definitely more productive. Definitely. I picked the best possible case for it. This is the type of thing that would be a pain in the ass to do manually. Um, but like ultimately, I'm writing the same code as if I forced myself to do this manually. Yes, graphs were huge. Graphs were absolutely huge. SPS. I think we hit 7 mil. We're gonna get up to 10 though. they're like this. I need these kernels to be I need these kernel profiles though before I can shave more. What's this? Okay. Synchronize this stream. Cap stream. Set this. Begin. End. Synchronize. Wait. Set. And synchronize. Oops, one moment. Okay. What does it mean to do for the tech? I had this exact issue before. We literally have the checklist. Don't start separate streams before tracing. End GPU buffers. Make sure input and output don't change. Restore original stream after tracing. Yeah. This synchronize was the one thing I did see, so we'll see if that fixes it. That was different. Yeah. Okay. Okay, let's see if this does it. Oops. Oops. The heck? There. Yeah, we still get the same error. Let me make sure we're using this the right. Are we using the right ones? Well, I mean, there's definitely that, but like also I think that this is, I mean, this is the best, like other than LLMs, this is the best candidate we have for like long-term progress in AI. There are a ton of problems that you'll just never solve with LLMs that you will solve with RL. It has direct applications in scientific simulation and like tons of logistics. There's just so many different places where this stuff is obviously useful if we can just make it sane and stable, and just nobody's done it. Okay, so we have C10. Real world impact is a measure of how much you think it impacts other people. That is not what real world impact is. I am embedding question for comms. If I have a scalar ob, such as a flag for being in check, I can split it out into a linear layer, yes. No need for stacking a one hot conv. Yeah, you can split it into a linear layer if you just, I mean, it depends where you attach it in the network though, right? So just make sure that you're not attaching it too late if you want the network to know about it ahead of time. Graphs are fully done. Can't recommend enough. I mean, I'm going to profile it to see what that's like wasting. I don't think breakout's going to be a good end though to test that. It's probably going to only be noticeable in big action spaces. I use many params when fewer params do trick. Ryan, the target for Puffer 4 is 10 mil SPS. We're already at 7. We are going to hit 10 for sure, but it requires custom CUDA help. Okay, now this is annoying because I actually have no idea why this is broken. Lots of luck, Spencer. When will I be satisfied? 10 mil sounds good. I mean, this is a 900 some odd line profile script from today. And believe it or not, this is actually quite compact. Like, it actually pretty much has to be this long. Like, or let's say if you were to make it shorter, you would actually make it substantially more complex than just the stupid thing that's long. With maybe a couple small exceptions on this one function. Um, Let me see. Wait, so mutable grad. Is it saving something? Oh, you know what? I wonder if you can't trace a backward independently. Let me try something real quick. So this is just going to be the backward graph, right? Maybe you can't graph, can you graph just the backward path? I wouldn't be surprised if there's something sketchy with that. Oh yeah, because we do torch empty and shit, right? Yeah, okay. Backward, yeah, there's no graph. I guess we can do this. I'm not thrilled about this. Forward, backward. Here's these. Okay, so I'm trying to think what we do with this. I don't I don't think that there would be an easy way to have this profiled. Do we actually need to graph the forward independently? I mean, I can subtract the time for the forward pass, but that's going to be misleading, isn't it? I'm trying to think what the best solution is. It's more than just the raw speed. It's also the precise understanding of where our compute is being spent. Yeah, people say there's a limit to hardware back when they were running RL at 1,000 steps per second. I've made it 1,000 times faster and I'm still going. Like, speed matters. The difference between RL working on like a single big node and RL working on your laptop is that if it works on your laptop, then RL will never ever be behind closed doors at companies. It'll just be out there and like widely distributed and being applied way, way, way more on pretty much everything. The theoretical limit is very, very far away from where we are now. And nobody even fucking understands like the how, where, and why of it because nobody bothered to profile. So, would we go about getting your Opus set up? Stop like asking it to vibe shit for you, right? Like watch the stream from the start if you want. Like this is, I mean, I've gotten a 945 line profile out of this. That's the same code that I would have written without Opus with Opus, but substantially faster and with a lot less bullshitting. And importantly, learning the exact same amount I would have learned if I'd written it myself as well. Repeat my current issue. So it seems like you can't graph the backward pass of a network alone because Torch has like a bunch of weird intermediate buffers. So I'm trying to think what I want to do about that because I know I can graph the forward pass and the backward pass together with an optim step. I think I can graph the forward pass and the backward pass together without an optim step. I'm not positive. Um, but then, like, I don't know if I want to subtract the time of the forward pass or what I want to do. I'm pretty much just trying to figure out how I want to approach profiling graphs. This is Claude Code, Jess. If you watch the stream, though, you'll see it looks completely different from the other day. Insert an event in the middle. Does that work? What would that do? The issue, I think, is that you're not... The way the backward is set up, it doesn't reuse the same buffers. It is probably, is it this mutable? It could be this, but then you also, like, you make empty tensors in backward as well that don't get reused. Let's take this and see if this works first. Because I actually don't even know if you can do forward backward graph without doing an optim step. MFU, garbage. You're membound, but like we don't even understand how membound you are. We're gonna try this. I know I can get the graph forwards. Let's see if this still breaks. Yeah, if I wanted to do that, it would probably be something like this. Is it like 300 T-flops or something? What's T? Is it E12? Giga's 9, yeah, E12 divided by, was it 1, 5? By 1E6. So this is in megs. Yeah, I think it's like 2 billion steps per second or something theoretical. The thing is, you're going to be way memory bound. You're not going to get remotely close. So you can't just do the flop math like that, man. You actually have to have an understanding of what piece of code is taking what amount of time. Okay, yes, you can compute memory bandwidth, but it's way more of a pain in the ass to estimate peak, um, like peak utilization. Okay, so this still breaks. Okay, so good thing I checked. The theoretical bound is mostly interesting if you're close to it. And again, it's very difficult as well to know what is a realistic theoretical bound or not. Men bandwidth is much more of a pain to calc. Okay, we can try this temporarily. See if this works. We can potentially just graph the forward pass if not. I don't like that idea too much, but we can just graph the forward pass if need be. Okay, so this is still breaking. Let's see if I can figure. Okay, so, and I have to go pretty soon because we got dinner to get to. But let's see if I can figure this thing out, or if not, maybe we'll just get something quick and stable. Just see if that does it. If not, we'll just do we'll just graph the forward pass for now. Too many optimizations. It doesn't interest me for now. It'll interest me when I'm actually pretty sure that I have puffer like close to where we can get it. Because then it might inform me of like additional things. Oh, yeah, that's bad, right? Oh, I'm just stupid. I'm just stupid. Yeah, that's not even what we're graphing. Gold. Yeah, we're not at scaling laws. The only thing we're scaling is fucks given about not letting your hardware waste all its flops. Do the same amount of work with a bunch of consumer GPUs? Hell yeah. Pufferell. We do offer professional contracts. Mostly for custom sim dev. But hey. I also did add, I added like a $200 a month sub on Twitter for like basic chat support as well for professional things. I've not really advertised that one yet, but it's still there. I mean, but it is there. If not, just start the puffer and continue enjoying. It is all free open source. This is fine. We're just gonna get the forward pass graphs profiled for now, and then we'll figure out the other things another time. Sim is the only thing we'd not be changing. I see. Well, we'll have a lot of fun stuff available in Puffer 4. Just open debates. We've got just like, we have basic entry. I mean, if you want to have a thing, we pretty much just added it as an entry level thing. But there's like a chat support thing you can buy on X that I set up. I kind of did it because I was sick of having a million Slack channels and also having to set up like tiny little contracts. So it is there. RL for derivatives. It's even more boring. That's funny. All right, cool. This works. Yes. And then right about here is where I'd want to stop anyways, because I'm starting to feel myself getting lazy. Single digit. Long, boring, and frustrating process. Okay. I am starting to get lazy, so this is pretty much the cap for today. Work on OSRS and neural MMO. I mean, it sort of does. Puffer is profitable. Growth has been quite good, especially considering that I spend most of my time on the research. I think we're going to, by the end of this year, pretty much like any individual like old school raid boss that you put in, like any boss, would just get one shot with RL. I'm pretty sure that that's kind of the level that we'll have, including the tougher ones. Obviously, you'd have to have a fast custom sim. I'm kind of using that to say like any medium complexity sim that's implemented correctly, I think we'll be able to just one shot. It's going to take Puffer 5 for that though. Puffer 4 will help, but we're gonna like there are a couple core algorithm advancements we're still going to need for it that I have planned. Okay, well, we got to check the timings. I think that there are still some issues with timings, and we're going to have to do a lot of checks. But this is solid progress. This is solid progress. Claude will create the M's. Nah. We tried that last time. That was terrible. Most likely, I'll end up creating some environments using some of the time that Claude saves me from dealing with torch bullshit. If that makes sense. Alright, this is now in Puffer 4. Solid day, 950 lines of code plus some modifications to other stuff. Need to fix some things. I'm not 100% sure these profiles are fully correct yet, but the structure is quite good. I'm going to have to do a bunch of checks, but like, once we have this will tell us where we are leaking perf, exactly how much, how useful our kernels are. Still some stuff, but this is like super solid progress for today. I'm happy with this. For folks who are new around here, you can follow me on X. I'm live here. I also post a lot of stuff, including articles, and the article about Opus will be right here and nowhere else in a few days. If you want to support my work for absolutely free, feed this puffer a star on GitHub. He likes stars. If you want to get involved with development, all our stuff is open source. Most of it is not this hard. Most of it is like low-level game dev that actually turns around and does help us advance RL research. So you can check that out here. Other than that, X is there, docs are here, all open source. Thank you all. Have a nice evening. I will be back maybe tomorrow. Definitely on Thursday.